This pre-calculus video lesson is on 6.4 polar coordinates. By the end of this lesson, you should be able to convert points and equations from polar to rectangular coordinates and vice versa. So to start, let's just talk about what our polar coordinate system is. Basically, our definition is a polar coordinate system is a plane with a point 0 called the pole and a ray from 0, the polar axis, as shown. Each point P in the plane is assigned polar coordinates as follows. R is the directed distance from O to P, and theta is the directed angle whose initial side is on the polar axis and whose terminal side is on the line OP. So remember, initial side is simply talking about our normal initial side being the horizontal generally from the origin if you think about your unit circle. So when we talk polar coordinates, here this polar coordinate P has two parts. Distance from the pole O to in the direction of theta. So two things to keep in mind is if that R value, that distance from O, is positive, then you're heading in that theta direction. If it's negative, you're heading in the opposite direction. Same thing with theta. Theta is going to be a direction from the horizontal going counterclockwise if it's positive. If it's negative, just like on the unit circle, you're going to start from the horizontal going to the right and head clockwise. That's when the angle is negative. So our first example here will be plotting points given the polar coordinates. So if I'm given the point 2, pi over 3, well, that means if I imagine here's that 0 and here's the horizontal, that's my initial side, then the point is going to be 2 units out at an angle of pi over 3. Well, we know pi over 3 to be 60 degrees, heading approximately in this direction, and it's going to be 2 units out. So the point we want, let's say, is right here, because this angle is pi over 3, and this distance is 2. But the actual point itself is just that right there, 2 pi over 3. This next one uses the point, or is the polar coordinate -1, 3 pi over 4. Well, again, say this is that O, our horizontal would head this direction. Well, 3 pi over 4, we know that that's in the second quadrant, somewhere approximately in this direction. However, our distance is negative, which means we're heading 1 unit in the opposite direction. That's the point that we will want. This would be -1, 3 pi over 4. And then the last example here, 3 -45 degrees. Well, again, this being our O, horizontal heads this way. Now we're going -45 degrees, which would be this direction, and we're going 3 units out, which would mean this is an angle of -45 degrees. This has a length of 3, which means this is the point we want right here. 3, +3, -45 degrees. some more notes here. If we're trying to find all polar coordinates of a point, we would want, if we let P have a polar coordinate, r comma theta, any other polar coordinate of P must be in the form r comma theta plus 2 pi n, where n is an integer, because if r theta is a point that we want, then if we go all the way around the circle, we have to add 2 pi or subtract 2 pi from that. Well, that, in so doing, we get back to the same point. So that would represent all the other points, or all the other ways of writing that in that same form. Or we could also go in the opposite direction, which would be negative r, but then we'd have to take theta plus 2n plus 1 times pi, which basically means we're going to go in the opposite direction, so we need the opposite angle. So this is just the formula to remind you how to do that. So understand, to get that same coordinate point r theta, we've got different ways of doing it. We can add 2 pi n, or we can go in the opposite direction and add 2n plus 1 pi to what we started with for an angle. These are the main coordinate conversion equations that you need to memorize. X is going to equal r cosine theta. Y is going to equal r sine theta. R squared is going to equal x squared plus y squared. And tangent theta is going to equal y over x. So when we're talking about converting from polar coordinates to rectangular coordinates, or vice versa, these are the main equations, the conversion equations we're going to have to use. So we'll be reverting back to these often. So the next example that we're going to do is we're going to find the rectangular coordinates of a point with the polar coordinates 2 comma 7 pi over 6. So in order to do this, we need to recognize that r equals 2 and theta equals 7 pi over 6. So to start, I know that my x value would have to equal r cosine theta. So x is going to equal 2 times cosine of 7 pi over 6. Well, you should recognize that's a nice angle to work with. You should recognize that cosine 7 pi over 6 is negative root 3 over 2. Since we're talking third quadrant, you know that both sine and cosine are negative. And it's going to be the same as taking the cosine of pi over 6. So 2 times negative root 3 over 2 is negative root 3. That's our x value. Same type of thing for the y value. Y is going to equal r sine theta. So y is going to equal 2 times sine 7 pi over 6. Get that the same exact way. We get y equals negative 1. So then we know our coordinate, the regular coordinate for the polar coordinate of 2 comma 7 pi over 6 is the same as negative root 3 comma negative 1. Simple conversion to go from polar to rectangular. On this next example here, we'll convert from rectangular to polar. Find 2 polar coordinate pairs for the point with rectangular coordinates 1, negative 1. So we're actually asked to find 2 polar coordinate pairs for the same point. So when we're given the point 1, negative 1, we know x equals 1 and y equals negative 1. Well, I know if I have x and y that r squared equals x squared plus y squared. So if I plug in 1 for x and negative 1 for y, I can very quickly get my r value. let's see, so r squared should say r squared is 2, so r would equal plus or minus root 2. Well, now I have r, I have x, and I have y. Well, I know tangent theta is y over x. What I need, since I already have r, is I need theta. So I'll just plug in those values. When is tangent theta -1? Well, there's a couple different options. If I take negative pi over 4, so if I'm in the fourth quadrant at a 45-degree angle or a pi over 4 radian angle, I know I'll get -1 for tangent. I know that the same is true in the second quadrant. Either of those would work. So I'm going to take both of those actually to write the pair of points that I need. So the distance is root 2. Since I want to head, if I want to head in the fourth quadrant, I can use the angle negative pi over 4, and I need to head root 2 in that direction. I could also say to get to that same point, 3 pi over 4, I could head in the negative direction using the angle in the second quadrant. So how did I know that I wanted to be in that, how did I know I wanted to be in that fourth quadrant no matter what? Well, from the original point. The original point was 1, -1, so I knew I had to be in the fourth quadrant. It was just a matter of how I wanted, or how I could use the r options that I found along with the theta options that I found to get into that fourth quadrant. So you're going to have different options. If you're just asked for one coordinate point, the answers could vary, but all end up in the same spot. Here's another example of converting from polar form to rectangular form. If I'm given r equals -2 cosecant theta, and I need to convert that to rectangular form and identify the graph, I'm going to take that r equals -2 cosecant theta and try to get it to look like one of the conversion equations that I know. Well, without too much struggle here, if I bring that cosecant theta to the other side, by dividing, well, r divided by cosecant theta, that's the same as r times sine theta. Well, if r sine theta equals -2, well, that's the same as saying y equals -2, because r sine theta is y. Well, what do you know about y equals -2 as far as the graph goes? It's just a horizontal line at -2. At y equals -2. Now, we want to support our graph using a polar graphing utility, so we know it should look like this. It should look like a horizontal line. Well, on your graphing calculator, you take that out. Again, you'll have to go into mode. Now, instead of going down to function, instead of going to parametric like we did in the last chapter or section, I'm going to go over to polar. I want to use my polar grid, and then if I go to y equals, I type in what they gave me. -2 cosecant theta, well, that's the same as -2 divided by sine theta. I plug that in. If I go to my window, 0, or theta minimum is 0, theta maximum is 6.28. Same type of thing with this. That's from 0 to 2 pi. The step we want small enough that it's going to hit everything that it's going to hit enough points that it looks like what we want. It's not going to leave holes in our graph. And then the y minimum and maximum you can change to whatever you want. I'll just do a -5 by 5 window with 1 for a scale, and then a -5 to 5 for for the y values, and then when we graph it, you'll see that gave us a horizontal line at y equals -2. Again, I would say experiment around with the calculator and see what you can get it to do with different values for different parts of these graphs. On this last example here, I'm going to convert from polar form to rectangular form. I'm given something a little more complex. I'm given this equation of a circle. So what I'm going to need to do is I'm going to need to expand this out. So if I expand this out, I'm then going to isolate the x squared and the y squared because I know what x squared plus y squared equals. So I'm going to bring those together. And then I'm going to substitute in using my equation conversion tools. So if I substitute r squared in for x squared plus y squared, and I substitute in r cosine theta and r sine theta for x and y, I'm almost going to be done already. Plug all those in. That's what I have. I can factor out an r. I then have r times r minus 4 cosine theta minus 6 sine theta equals 0. Well, obviously, r could equal 0 to get that answer. Or, if I set r minus 4 cosine theta minus 6 sine theta equal to 0, that would be the same as saying r equals 4 cosine theta plus 6 sine theta. So the r equals 0 is a single point that is also on the other graph. So that means that the equation is r equals 4 cosine theta plus 6 sine theta. What did we just find? We just found a way to convert this graph to polar form. To change that graph to polar form, we got this. R equals 4 cosine theta plus 6 sine theta. I would say then graph both of those and see how they are the same.